Thank you, everyone, and thank you, Brian, for the warm welcome. I see both of my managers sitting on over there and cheering up for me and also making me a little nervous about my talk. But that's all right, that's my part of the job. They're evaluating on my public speaking skills. Well, I'm a machine learning engineer at PathStack, and today I'm talking about multi-agentic security pipeline in the WordPress ecosystem. Just a tip, I am an Indian, so if my enunciation of some of the words are not clear, I apologize, but I'll try my very best to be as clear as possible. All right, so.
Welcome everybody to LoopConf. Let's get ready to learn, laugh, and loop our way to amazing experience.
I hope Obama hasn't, dissatisfied with his generative AI technology. Like, we can use all these Gen AI technologies to get the welcome from him. Privileged to have Obama welcoming us here. All right. So, getting back on the main part of the talk. So this talk, I really would love everyone to have equally participating because I'll be asking a bunch of questions and there is nothing wrong in right answer. But at the same time, also help me to evaluate because I built AI workflows, so it will be helpful, as feedback, how we can improvise the existing AI workflows. And the slides and the code will be open source. So you can always access at the end of the presentation. There will be a QR code which will be shown over there. Since we already know that majority or 45% approximately of the internet is built on the WordPress, which means it has a huge footprint, which means it implies a lot of responsibility. So any possible trap or a failure could lead to a lot of system issues around it, right? And in last year, there were a bunch of new vulnerabilities identified within this ecosystem. And I would love people to give a stab on this question and what could be the number, or just think, you can always guess around it, how many new vulnerabilities were identified in 2024 within the WordPress ecosystem. There are 4 options. Of course, one of them is correct. So that's a hint that I can provide it to all of you. But would like to hear, what do you think? Is it the answer? Let's just go with 1. Anyone would like to raise a hand? Good. Okay, what about the second option? Interesting. Both my bosses have raised the hands. So I better, if their answers are wrong, I'm going to complain to anyhow. So what about the third option? Wow. Majority. Interesting. And what about the last one? Good. Okay, so the correct answer is 1, the first option. Both my managers have said like the option B, so they are themselves not aware about it. Sorry for using both of you as a bait and the temptation to fill in those gaps. So this is a state of the WordPress newsletter or the white paper being released by the PathStack, the organization where I work for. And they have mentioned that how many vulnerabilities were identified, what were the reasons, where the majority of the vulnerabilities were identified. So it's a very nice paper in, not technically dense, but equally lubricative to understand. So it states that 7,966 new vulnerabilities were identified in 2024 alone, which is a majority, like 30%, I think. Yeah, increase from 2023. And this trend is continuing over the years as well. You must have seen or used Cursor AI tool, which is AI assisting coding tool editor. And it also has RCE, remote code execution vulnerability, which means if the hacker has the access to your system, they can inject the code and they can run the code on your system, right? So are we aware about all these security issues in the pipeline, which is happening with all these Gen AI / the existing software? So it's important to be aware about this. And throughout my talk, I will try to influence and inspire people to think through a different lens altogether. And also want to ensure that my lens of thinking is not perfect, but at the same time, it's important to think from a lens of the security perspective of what existing tools are facing security issues around it. So this is also one piece of the white paper, which says that WordPress ecosystem has multiple components to it, right? It has themes, plugins, and so on and so forth. So it says that the plugins, like 96 of the vulnerabilities, 96% of that was identified in the plugins in itself. Of course, you will see the status whether the majority or the low, they were like low vulnerabilities or a medium or a critical, but still there is like 96% of those vulnerabilities were identified in the plugins. There is another statistics in that white paper which states that majority of those vulnerabilities were XSS, right? And then of course followed by broken access control and so on and so forth. So these kind of analysis is really important to understand the code or the systems that we are building. Are they bound to some system failures? Are they having some design gaps? Or are they having some coding mistakes, which as a developer, we are also not even aware about, right? So impact of these vulnerabilities is not leads to, the reputation loss, right? Like there was a CrowdStrike incident which happened and a lot of microservices, I think Microsoft architectures and systems were down. Like some of the flights were even canceled. So it was not just the reputation cost which happens to a brand or a company, which is even the tip of the iceberg, but it also leads to penalties. And those penalties I meant by could be, the monetary penalties or could be security penalties, and there will be imposed some GDPR, all these kind of issues are all around. And of course, the loss of assets and the trust of the customers, which is very vital in order to maintain for running of the business, right? Now I want to shift the gears. Now I explain why security is really vital, what could be possible issues around. Now I want everyone to be on the same page. So I'll go on the basics and just like a couple of slides will gear on top of it. Like what exactly is AI, why there is so much hype of Gen AI which is happening, right? So AI, it's nothing, it's kind of mimicking the human behavior, like the way that we respond, how we respond to the stimuli, how do we react to it, right? And machine learning, it's a subset of AI, which is extracting the patterns and the ability of the machines to learn from that data given to it. The example over here is a spam filtering, like in the Gmail we see always, there is a spam email which is coming. So it's machine learning or algorithms which is running behind the scenes. And then the deep learning is another subset, which is extracting the patterns from the data using the neural network. So you don't have to have well-defined data set or a labeled data set. So deep learning, it's like the advanced technique, which is extracting patterns from the data and synthesizing brand new data instances. For example, the handwriting recognition. Now I have explained the basics. Time to test you all. So I want you all to take a minute and think. Think which of these faces are real faces. I won't be providing any hint this time. Okay, is it the face A is a real face? Excellent. Is it the face B is the real face? I got you. Okay. What about the face C? Is that a real face? Come on, I would like the participation of people. I know we are towards the lunch break, and I promise I won't eat up your lunch break timings. Okay, what about the face C? Do you think face C is a real face? Very nice. I love that. Hand raise by people, So the answer is none of them are real faces. So I've not been to the extraterrestrial planets, but these faces are synthesized and generated using the existing human annotated data set. And this is an example of how we use generative AI for, image generation, let's say an example around it. So what happens behind the hood is the model itself learns the patterns from the existing human data, and then it generates or synthesize brand new data instances so that it's easier to, like make it as if it's a real face, but actually it's a fake face. All right. Behind the hoods, so this is again a mathematical, but we don't have to go in deeper, but just a basic idea and understanding is behind all these generative frameworks, we have this transformer model, which is running behind the scenes. It's a stack of encoder and decoder, which means that whatever the information is coming in the model is absorbing and then synthesizing patterns around it and generating the response around it. So if you see GPT-3, and in fact now it's GPT-5, right? So what it is doing is it's using this transformer model. It's a scalable model. It's released by Google, and there was one of your favorite paper was "Attention is all you need." So the paper title was very catchy, which means attention is all you need. Is in order to grasp all the information which is being fed as an input, the model should be able to understand it and synthesize the new generation of the data. Okay. So LLM use cases, right? We use it for code generation. We use for so many other purposes, summarization, so on and so forth. But for this talk, or for especially, for security use case, let's dig on one problem, which is the vulnerability detection, and of course, building some security workflows around it. And these are the use cases like LLMs are used. Here, the example is given as next token prediction. To get an intuitive understanding, what happens in the generation part of the models is they give you the response based upon the probability. Like what is likely to come next? Like what is the next token possible? Here, the response the model has given butterflies. It could be people, it could be flowers, something else. So here the model is saying that the garden was full of beautiful butterflies. So it must have seen the data through which it has given you the response with a certain confidence, like 90% confidence or a certain probability around. And similarly, the response could be different. It could be a flower or something else. So the statistics is the building block behind all these, LLMs and building all these kind of responses by the model. First use case, let's see. So here, the use case that I'll be building, along with both, all of you is, so we are having the open source data set, which is given on the Kaggle. Kaggle is like a marketplace where you can get the access of the data, models, and also see the notebooks of the people, those who have worked on a certain, code or use case before. So here, the use case is build a multi-agent pipeline that analyzes the patterns, community health, threat intelligence, and the code quality, and provides the recommendations as well as prevents the risky plugin installation. So let's say we have already our WordPress website, we want to install new plugins onto it, right? So we need to get the recommendation from the system itself, like which plugin should we install. And in order to get that recommendation, it is looking on certain features, and that's why we are building a multi-agentic system. And that agentic system is looking for patterns, health, threat intelligence, and code quality. I'll show first the data, but before even showing the data to all of you, before even going in the coding or the implementation, I want to explain some basics of what is multi-agentic, why there are so many people talking about, let's build the multi-agentic workflows, what exactly it is. So there could be impossible architectures, however you define for your business use case, but the simplest part is let's have a single agentic mechanism or a tool which is doing some tool calls, right? It could be doing some summarization, it's calling a Claude Code or something else. And there is a network architecture, which is like every agent is specialized to do a certain task or set of instructions, and then it gives the response from one agent to the another. So basically input from one agent is being fed as in, like the output of one agent is fed as an input to the another agent. So that's a network architecture. Supervisor architecture, I find it very similar to as a master-slave sort of an architecture, which is kind of orchestrator, like every agent is responsible for its own specialized task. And then the manager agent is going to give a consensus. Okay, this is how the response should look like, and this is what the agent should work on this particular, assigns the rules and responsibilities so that integration is easier. Just to give an example of the supervised agent architecture is, so let's say there is a user query and then there is a supervisor agent which has multiple agents all together, and all these agents are calling different tools for specialized tasks. I'll explain through an example so that it becomes intuitive. The example that I'm taking here is a very basic report generation, which is like, okay, you want to synthesize a report from various sources of information which is coming in. Let's say there are some security articles being published by the different, customers, or let's say companies or organizations altogether. So you want to synthesize a report. A report is like summary, so you don't have to read every possible architecture, right, or every possible blog. So here what happens is, first it is going to do the web search task. So there is a web search agent, which is, of course, it can be calling like DuckDuckGo or some other API, like the Google Search API or SERP API, something like that. There is another, which is trend analysis task. So it's a trend analyst agent. So it's basically searching on the Google and finding what is going latest in the trends itself. And the next one is the reporting and the proofreading task. It has generated some report, and then there is a proofreading. So all of the culmination of all these agents, whatever the response is being given, it's being fed to the manager agent, and then it can produce a final report. So this is an example of a supervisor agent architecture. So we'll be using similar for our use cases and for plugin quality also. Okay, here the data which is from the Kaggle, it's I've just screenshot a small subset of the data, but it has a lot of plugins. It has something 25,000, some more than, in fact, plugins. So basically for all the plugins, like on the WordPress ecosystem, it has a slug, version, tag, tested, rating, and so on and so forth. And also the active installs, like how many people have installed that plugin and what is the download. You can always see all these kind of information on the WordPress website for a specific plugin. So here, first I want to define the architecture, want to show what is the response or the result will be given, and then I'll go on the code snippet, so that will be easier to ingest that information. So this architecture says that first you have the WordPress plugins metadata, because we saw the data on the CSV format, which was given already to us, and then we have built a multi-agentic layer. So if you see in this multi-agentic layer, it has multiple agents. Like it's following the same supervisor agent that we saw the architecture in before, right? It's using the community trust. And what community trust agent is going to do? Like every agent has a specific task to complete. First, it is checking what is the rating and the reviews of the customers, those who have installed that plugin. Then it is checking active installs, support threads, like sometimes there is a vulnerability or sometimes there are some issues which some customers are facing when they are downloaded the plugins. So like all this information was already given in the data. So therefore I've defined one agent who is going to analyze all this information, and therefore it is called as a customer trust agent. You're free to define whatever the name you like, but I feel like it should be intuitive to understand. The next one is the vulnerability intelligence agent. So here it is for all the slugs or / all the WordPress plugin which was given in the data. It is identifying which of those plugins have security issues recently being released. It's also using an API which is from the VB vulnerability API in order to get that information from the database itself, and then also like the risk signatures. Next is the code quality agent, which is identifying the plugin functionality and what compatible the plugin is to which WordPress version, and PHP compatibility as well. So it's basically, if you see in nutshell, it's kind of a weighted mechanism which at the end in the consensus agent is defined, right? You can always play around with how much percentage you want to define. It's all based upon hyperparameters. You tweak around it, and then you see which model is performing the best or which agent is giving the responses around it. And then towards the end, it gives you the security assessment, whether you should install that plugin versus not based upon your use case. So this is holistic. The idea was how we can build a plugin security analysis agentic architecture. And if you see here, the response. So here the response, I have used like multiple plugins because it was hundreds and it was so much like the plugin. So I just attached the response of one of the specific plugin, just make it sure intuitive to understand. If you see here, it says that, also I'm using the GPT OSS model. So OpenAI has released open source models, right? I'm actually a big fan of using and fine-tuning the open source models. Don't have to rely on the API outages which happen. Sure, they're not the state of the art, but they help in really understanding which models are performing the best. So it's better to fine-tune them and tame them for the use case. So here, once I've used the GPT OSS 20 billion parameter model and through Ollama, I've used it, then it gave me the response, which is really crystal and clear to understand. So it gave me for PS multi-languages plugin. And these are the these are the key concerns. The users are given a rating of 66 on 100 while it's not terrible, coupled with a low rating count such as user dissatisfaction. So the recommendation is, proceed with the caution, right? It has given the nice and fabricated response around it, which is human comprehensible, that whether you want to install this plugin versus not. And also at the same time, it has said that the WordPress compatibility is a major issue, and the plugin was tested on a certain previous version of the plugin, right? And now the WordPress, it's 6.6 plus. So you need to be cautious about the fact when you are installing that plugin. So building these small tools is really efficient in order to understand how we can use LLMs for our use cases for the security workflows. So this is one example. As I was explaining, I'm not sure if it's visible at the back, but I can read out the important elements around it, which is I'm using the model, again, as I mentioned, GPT OSS 20 billion model being released by OpenAI, so we can use for our use cases. The reason why I use this model is because its reasoning capability is as comparable to the O4 Mini, which is a closed source model. It's a state-of-the-art model, but again, it's a closed source model, right? So this one is the open source, so I'm using that. And of course, I just pulled this model through the Ollama, so it was easier just to make a check whether this model is even available versus not. If the model is not available, then we just have to do Ollama pull and the name of the model itself. Over here, if you see, since I mentioned that there were 4 different type of agents, right? So if you see in the community trust agent, there is a certain plugin or the prompt which I've used. Analyze the WordPress plugin community trust based upon a certain metrics and then give me the response in a certain fashion all around. Always play around with what should be the better context engineering or prompt engineering around should be, but this is how the response it is giving. Similarly, we have a code quality agent. How can we define what is the quality of the agent of the plugin? Then we have update frequency. It's vital to understand if the plugin is getting updated frequently versus not, because if it's outdated, right, and it's not supported to a certain version, boom, your website. This is another agent which was doing that, and then threat intelligence. So as I was mentioning that for the threat intelligence, it was important to understand. It's also using the plugin API because we have the database of the PP vulnerability API. If there are already security issues from there, or the plugin already has, so there is a regex pattern match you can do. So towards the end, it gives you the brief explanation that why this plugin has the vulnerability around versus not. So that's why you need to be cautious about installing on your website. So this is how the consensus agent gives the response at the end. Culminating all the results from all the particular agents and then giving the response at the end of it. I think I can show this live also. Let me try my luck. Sorry. This is the plugin quality agent. I hope it's visible at the back. So as I mentioned that I was using GPT OSS 20 billion model and checking whether the model is even available versus not on the Ollama interface itself. And then I'm keeping the temperature as constant. It's better to keep it as constant and with a certain parameters around it rather than to tweak, because the model can fluctuate, giving the response from a wide range, which we don't want. So that's important. And then categorizing what possible risk could be, like a medium with a certain confidence around. And this is the community trust agent, the snippet that I showed before. The one that I showed on the slides were not complete. It has certain other layers around it, but it gave you the basic idea of how I built that. Then identification of the vulnerability patterns. For here, right now you see that high-risk patterns is not an exhaustive list. So having not an exhaustive list, and then I plugged in the VP vulnerability API in order to get what particular patterns are there within the WordPress ecosystem, right? Like how to identify the security issues around it. So that's how I plugged that API. Then at the end, as I mentioned, that there are certain weighted average, like you are assigning the weights to every particular agent in order to define, and then it gives a response. So this is how I did for the consensus agent. And let's actually, meanwhile it runs, I just want to give like the huge, not huge explanation, but the response we are expected to get is, it's going to ask me like how many plugins, for how many plugins do I want to see the results? Because the data has like, it's huge data, right? So for the demo purpose, we can just choose like 5, 10 or something like that. Well, by the time it's running, I think I can go on the next use case as well. Yeah, but the expected response should look like this, that for every specific plugin, there is a response which is coming in, right? Like, what is the final assessment, whether we should install that plugin versus not. Okay, so, yeah. So instead of asking me enter the choice, as I mentioned before, it has taken the default. So for the top 10 plugins, it's going to give a response. Okay, finally, yeah, we got like at least for one plugin. Which says with 92% confidence that, okay, if you want to install this plugin, you need to proceed with the caution, and this plugin has not been updated for the last 2519 days. I don't know how many years that turns into, but seems like you should not be installing that plugin, right? So, this will continue go on. Yeah, okay, I'm gonna stop this and proceed to the next. So the next use case, which is highly, introspective, and of course, it's really, I feel like it's important to understand why we need to build some certain kind of vulnerability detection use cases. And here I'm using a multi-agentic framework, which automates the detection of the security vulnerabilities in the WordPress plugins and generates the patches and then validate the fixes. Like whatever the patches the model has generated, it has to validate those fixes as well through a coordinated set of AI agents. So that's our second use case that we will see. For this use case, I have bifurcated it into 3 main phases. The first is vulnerability detection agent. The reason why I have bifurcated, because every agent is analyzing and doing a specific task, and those tasks involves like bunch of set of rules, not just like a simple set of rules, right? And for this one, for detection agent, here what I'm using, again, I'm using GPT-OSS 20 billion model. For this use case, again, I've used like VP vulnerability version APIs. Why I've used that? Because it has a database of a lot of security issues, which is within the WordPress ecosystem. So that was easier to even identify and build on top of it. And then it gives you the final verdict. If you see the final verdict over here, so I will not show from which plugin the response is coming in from, but it's one of the sample plugins which I've analyzed, and it's a contact form 7, but like years ago it was deprecated now. So that plugin has like bunch of security loopholes to it, and it also gives a number, or the line number, like which particular. It doesn't give you the the exact number, like the exact name of the file, but it gives you the line number and also tells you, okay, this is the particular vulnerability in that plugin and the reason behind it, and with a certain confidence, like 95% confidence around it. So it's the first initial layer of building an agentic system in order to identify the issues or security loopholes in a plugin. For that, again, as I said, that entirely all my use cases throughout this presentation is built on top of GPT-OSS, through which I have fine-tuned and used certain existing security analysis. Here, the temperature is also like 0.1, just to maintain the responses as constant as possible, and then, it gives you the response around it. Let's see if I can actually, yeah. So here the set of the vulnerabilities, if you see here, those are very small, like only a small subset of the vulnerabilities I have defined. Okay, these could be possible vulnerabilities in a plugin, but of course there are exhaustive list of it, right? So just for the demo purpose, I'm using a small pinch of, the vulnerabilities. And then when we go under it, we'll see again the model which we are using and then checking the model vulnerability, availability. Here for every, like the prompt that we saw on the slides was, for every vulnerability, respond with the JSON format, like what should the format look like. If there is no vulnerability identified in a plugin, then return with a null as a, response. So we can run and of course, just see the response around it. I want to actually go on the next part because I see the 10 minutes is over there. The next is the patch generation. So first you have identified the vulnerability, you need to fix it, right? Like for patch generation, what I'm doing, using the vulnerable code which is identified in the first stage. That's why I said that output from a first agent will be fed as an input to the next agent, and therefore the first agent, which was vulnerability detection agent, it is whatever the response it is giving, it is saved in the DP, and the patch generation agent is taking that information and building on top of it. So here what it is generating is, it's generating a patches like how to fix that issue once we have identified that issue. And then it gives you the results around it. So there are like two things which here the model is doing. Not only just checking the syntax, but the security loopholes and also validating, building like the custom test cases, whether that particular vulnerability is not a false positive or whether that's a valid versus not. So there is like custom set of the test cases built over here. As you can see here, the first example which says that, okay, this is a patch code for a certain explanation, like the explanation corresponding to it, and then it gives you with a certain confidence and what were the test cases which were run in order to build that patched code. Here it's seeing the temperature is the same and the constant. For here I'm just using like the top 60 so that the response is generated on that. But this is where main part of the prompt engineering lies in. That, okay, the response should be in the JSON format. You need to include like the relevant test cases, and those test cases are already like in a template format given so that the model understands before even generating the patch code and validate it. There is also a mechanism of called as a knowledge-based generation. For example, if someone has already patched a vulnerability or there is existing pattern which is existing in our data set, so it's easier for the model to compare and do some regex search on top of it. The last one is the patch validator, which is once the model has detected the vulnerability, it has generated a patch and a fix, can we validate whether it's even possible to exploit that, or whether it's even possible that, it's a valid vulnerability. So here it's using a bunch of test cases like the algorithmic strength test, there is a pattern compliance test, and there is a payload injection test. And then on top of it, it is using GPT model, this open source model, before even giving the final response in a form of a comprehensive report. And here's how it looks like. If you see here, the first one is, SQL injection example it has given, right? The original, what was the code, and then the second is the patch code. If you see in the original, right, like the ID could be a post ID. So basically, if anyone could put any ID, then it means people can get the access to the entire database altogether. But for the patched version, it says, no, it has to be in the string format, like a specific version or the type of the response it should give. And then if you see, with a certain confidence and with whether it's actually should be, whether the model has generated the right patched versus not. So here you can see in the validation end, it's saying, okay, the vulnerability has not been fully addressed. You better take care of that, right? So these use cases are really important to understand while we are building this patch generator agentic mechanism in order to identify and mitigate the vulnerabilities in the different WordPress ecosystem. Or here it's the same GPT OSS 20 billion model. If you see here, the comprehensive result, it's not generating just a syntax validation, it's also doing security validation with a certain confidence score and a performance, and along with it, the AI analysis of the model. Yeah. So now I've explained on a very high level how we can use, team some of these open source models. Now it's important to understand what are the challenges, right? So that's even important because yesterday I was talking to someone and someone was like, oh, you know what? Don't talk to me about AI. I'm not really fan of AI. It produces gibberish results. I was like, sure, but we should not exclude the new tools. We should be using all these new tools which are coming up. Well, first is AI does hallucinate. Confabulations. It's AI does produce the results which seems like plausible, which seems correct, but actually those are factually incorrect, right? For this, I want to test the human intelligence here, and that's a very basic question. As an Asian, I love maths, right? So I'm going to ask you one of my maths question was, if Alice has n brothers and she also has m sisters, then how many sisters does Alice's brother have? Basic question, right? Yeah. Okay, who does think the first one is the right answer? Please raise your hand. Okay, thanks, John. What about the second one? Very cool, intelligence audience. Okay. What about the third one? Wow. Okay, what about the fourth? Come on. Yes, fourth is not the right answer. But let's see what the model has given. And that's what exactly John gave the response. It should be n plus 1. But the model has given, and the model, if I'm using, I don't know if it's visible on the back, it's using the Gemma 3 too, right? Like a 327 billion parameter model, which was released like a month or two ago. Yeah. Well, so the answer is n plus 1. I hope everyone knows the reason why, right? Like you have to consider Alice herself. So models do hallucinate. Oh, this one is very nice. Translate this from English to Vietnamese. So I was asking, what is the capital of Vietnam? Even though I know, but still wanted to play around with small prompts. I have no idea what does this Vietnamese language imply, but let's just assume what of the answer, and please guess. What do you think the first, what is the response going to be by the model? Is it the first answer? What do you think the model is going to respond back? Anyone? Interesting. So I was just asking, what is the capital of Vietnam, right? We know that's Hanoi. So, and what about the second? Do you think the model is going to give response second as a response? Interesting, Brian. Oh, wow, Zoe, you're also saying, okay, cool. Well, this is what the model said. I asked for the translation, not the response. Come on, that's a Mistral 7 billion model. Anyone who is a fan of the Mistral, sorry and apologize, but your model really sucks. Okay, so hallucination is a known fact, right? The models hallucinate. When you're not providing enough context or you're not building the RAG or the knowledge base around, the models tend to hallucinate when it doesn't have the context or what you really want to ask around. But if you change and tweak the parameters of the model or tweak the prompts even for the model is going to give the response which is expected by the user, right? So there is no denying the fact the model is not going to hallucinate. There is a well-known paper as well, The Man is a Programmer, a Woman is a Homemaker. It's released by the Google, which says that the affinity of the woman is more towards a homemaker as compared to a man. The reason why the model gave such responses is because it was trained on a biased data set. So if you have garbage in, garbage out, right? If you're feeding the bad responses or the information in the model is going to give you skewed distribution. It's going to give you the response which is hallucinating, right? So it's important to aware about that we should not rely on the LLMs. And some people were afraid. Yeah, last night someone was saying that, oh, am I going to lose my job because of the AI? If this is what AI is going to give, I don't think we are there yet. All right. And the next one is, so the limited context window, right? Like now the models are getting expert, they have like 2 billion context window around it. But even some of the important and the core reasoning models, they have, like 8192 tokens. By tokens, I mean the word. We read the novel, and the novel is not even like 8,000 tokens. It's just like a children's book is 8,000 token book, right? So models have a limited context window or limited capability to understand all the information. So it's important to understand the limitations of the current ecosystem and build on top of it, and not to rely on LLMs as per, for building all the use cases altogether. But definitely it's important to explore such systems around. At the end, I want to highlight that cybersecurity is not an expense. It's definitely an investment, because we really need to be aware about what are the security loopholes in our current ecosystem, and LLMs are not going to take our jobs, at least in the near future. Thank you. That's all I have for you today.